Factors contributing to reduced longevity in individuals over 80. A significant portion of individuals over 80 have a limited life expectancy. This raises crucial questions regarding the underlying causes, whether natural aging processes, prevalent diseases, or other yet-to-be-identified factors. This analysis will explore the alarming reality of shortened lifespans among the elderly and identify potential interventions to promote extended healthy living. Understanding these factors is vital for improving longevity for oneself and loved ones. 1. Biological aging and cellular senescence. Biological aging is an inevitable and natural process characterized by the progressive decline in the ability of cells and organs to maintain and repair themselves, ultimately leading to a systemic functional deterioration. This complex process is influenced by a multitude of factors, including, but not limited to, cellular senescence and telomere shortening. Telomeres are repetitive nucleotide sequences located at the ends of chromosomes, acting as protective caps that shield DNA from damage during cellular replication. Critically, telomeres shorten with each cell division. Once telomeres reach a critically short length, cells cease dividing, entering either senescence or programmed cell death, apoptosis. This telomere attrition significantly impacts cellular and tissue regeneration. The resulting decline in tissue renewal capacity directly contributes to the functional impairment of various organs, particularly those with high cellular turnover rates, such as the skin, blood, and intestinal lining. Furthermore, shortened telomeres have been strongly implicated in the pathogenesis of numerous age-related diseases, including cardiovascular disease, cancer, and immunodeficiency. The progressive shortening of telomeres, therefore, represents a key mechanistic contributor to the multifaceted decline associated with biological aging, highlighting the importance of understanding and potentially mitigating this process to promote healthy aging and longevity. Cellular DNA damage stems from continuous exposure to harmful agents, including UV and ionizing radiation, which directly attack DNA, inducing gene mutations. Environmental toxins, air pollution, food chemicals, cigarette smoke, which damage DNA and increase cancer risk, and reactive oxygen species, ROS, generated during energy metabolism, which can destroy DNA, proteins, and cell membranes. The body possesses a DNA repair system, but its efficiency diminishes with age. The accumulation of unrepaired mutations can disrupt essential gene function, leading to cancer and organ degeneration. For example, DNA mutations in skin cells can cause skin cancer, while mutations in nerve cells may contribute to Alzheimer's or Parkinson's disease. Mitochondrial dysfunction and increased oxidative stress are significant contributors. Mitochondria, the cell's powerhouses, produce ATP, the primary energy source for life. Mitochondrial decline results in insufficient energy production for cellular function, leading to reduced ATP production, causing weakness, decreased endurance, and increased fatigue. This also increases ROS production, inducing oxidative stress that damages DNA, proteins, and lipids, accelerating aging. Mitochondrial dysfunction is a critical factor in neurodegenerative diseases like Alzheimer's and Parkinson's due to the brain's high energy demands. Consequently, the elderly experience increased fatigue, rapid exhaustion, and slow recovery from physical activity, along with muscle weakness, increasing the risk of falls and fractures. Stem cells are undifferentiated biological cells that can differentiate into specialized cells and can divide through mitosis to produce more stem cells. They are crucial for the regeneration and repair of tissues throughout the body, playing a vital role in the replacement of aged or damaged cells within various organs and systems, including skin, blood, bone, and numerous others. The decline in stem cell function and quantity with age significantly impacts the body's regenerative capacity. This diminished capacity leads to a cascade of age-related physiological changes. The aging process is characterized by a progressive reduction in both the number and functionality of stem cells. This reduction directly translates to a slower rate of tissue regeneration and repair. Consequently, wound healing is impaired, increasing susceptibility to infection and prolonging recovery times. For example, a minor laceration that heals within days in a young adult may take weeks to heal in an elderly individual and carries a heightened risk of infection. Furthermore, reduced blood cell production contributes to anemia and compromised immune function, leaving the elderly more vulnerable to various illnesses. Osteoporosis, a debilitating bone disease, is also more prevalent in the elderly due to the decreased efficacy of bone-forming stem cells. This decline in stem cell activity is further compounded by a deterioration in the body's ability to maintain homeostasis. Homeostasis refers to the body's intricate mechanisms for maintaining a stable internal environment, encompassing the regulation of temperature, blood pressure, blood glucose levels, and hormone balance. The disruption of this delicate equilibrium has far-reaching consequences. A compromised cardiovascular system results in increased blood pressure fluctuations, significantly elevating the risk of stroke. A weakened immune system renders the elderly more susceptible to infections, including influenza and pneumonia. Impaired glucose regulation increases the likelihood of developing type 2 diabetes. Finally, hormonal imbalances, such as decreased testosterone in men, leading to muscle loss and reduced energy levels, and decreased estrogen in women, increasing the risk of osteoporosis, further exacerbate the effects of aging. The inability to effectively regulate body temperature, for instance, makes the elderly more vulnerable to heat stroke, highlighting the profound impact of compromised homeostatic mechanisms on overall health and well-being. The body's reduced capacity to adapt to sudden environmental changes, whether extreme heat or cold, underscores the systemic nature of age-related decline. 2. The burden of chronic illness. Chronic diseases are long-term conditions, typically incurable, that significantly impact quality of life. The prevalence of these diseases increases with age, imposing a substantial burden on individuals, families, and healthcare systems. Chronic diseases are characterized by slow progression, persisting for years or a lifetime, often involving genetic, lifestyle, and environmental factors. While complete cures are unavailable, effective management is achievable through medication and lifestyle modifications. Key characteristics include prolonged duration, necessitating long-term health management, the absence of a definitive cure, mandating lifelong treatment, the potential for severe complications, demanding vigilant control to mitigate health deterioration, and substantial treatment costs, contributing to significant personal and societal financial burdens. Cardiovascular disease encompasses hypertension, atherosclerosis, heart failure, and stroke. Prolonged high blood pressure strains blood vessel walls, while high cholesterol leads to arterial blockage. Sedentary lifestyles and unhealthy diets are significant contributing factors. The consequences include stroke and myocardial infarction, leading causes of death globally, resulting in impaired mobility and diminished quality of life. Type 2 diabetes is characterized by the body's inability to regulate blood sugar levels, often stemming from obesity, inactivity, and poor diet. This can lead to kidney failure, blindness, and cardiovascular disease. Nerve damage causes loss of sensation in extremities, increasing the risk of foot ulcers and amputation. Chronic obstructive pulmonary disease, COPD, is primarily caused by smoking, but also by air pollution and exposure to hazardous work environments. COPD results in shortness of breath, reduced mobility, respiratory failure, and increased mortality risk. Cancer arises from accumulated DNA mutations over time and exposure to carcinogens such as tobacco and harmful chemicals. Treatment is costly and painful, severely impacting health, with high mortality rates if detected late. Musculoskeletal diseases, including arthritis and osteoporosis, result from age-related cartilage degeneration, calcium deficiency, and vitamin D deficiency. These conditions cause joint pain, restricted mobility, and a heightened risk of fractures, particularly in the elderly. The escalating burden of chronic diseases is attributable to a confluence of factors, with age playing a significant role. The aging process inherently weakens the immune system, diminishing the body's capacity for self-repair and resulting in reduced efficiency of vital organs such as the heart, lungs, and kidneys. Furthermore, unhealthy lifestyle choices significantly contribute to this increase. Smoking, for instance, is a leading cause of pulmonary diseases, cardiovascular ailments, and various cancers. A diet rich in processed foods and fast food increases the risk of obesity and diabetes. Sedentary lifestyles exacerbate the risk of cardiovascular disease and musculoskeletal disorders. Excessive alcohol consumption inflicts damage on the liver and elevates the risk of cancer development. Finally, Environmental pollution, including air pollution and exposure to harmful chemicals, presents a substantial threat, increasing the likelihood of respiratory illnesses and various cancers. These factors, acting individually and synergistically, create a complex and challenging public health issue demanding comprehensive and assertive intervention strategies. Chronic diseases impose a significant socioeconomic burden. High treatment costs are incurred due to the prolonged nature of these conditions, necessitating ongoing medication, testing, and potentially surgery. For instance, individuals with diabetes require lifelong insulin therapy. Reduced workforce productivity results from increased absenteeism among those with chronic illnesses, who require frequent medical attention, impacting their ability to maintain employment. Furthermore, a substantial strain is placed on families and healthcare systems. Caregivers bear the responsibility of providing extensive support, demanding significant time and effort. The escalating number of chronic disease patients contributes to the overwhelming burden on healthcare facilities. Effectively managing chronic illnesses. Maintain a healthy lifestyle through a balanced diet, low in sugar and salt, and rich in green vegetables. Regular exercise is crucial for cardiovascular health. Smoking and alcohol consumption should be minimized. Regular health checkups are essential for early disease detection and effective treatment. This includes monitoring blood pressure, blood sugar, and undergoing routine blood tests. Optimal disease management requires strict adherence to prescribed medical treatments and proper medication usage for early disease control. 3. Significant decline in both physical and mental resilience. Resilience is the capacity of the mind and body to adapt, withstand, and recover from injury, stress, or illness. This capacity diminishes with age, resulting in slower recovery from illness or injury, physical decline, including muscle loss, osteoporosis, and reduced cardiopulmonary function. Cognitive decline, including memory loss, psychological stress and depression, and difficulty adapting to environmental or lifestyle changes. The mechanisms underlying the decline in physical resilience are multifaceted and interconnected. Firstly, a compromised immune system significantly contributes to reduced recovery capacity. Weakened immunity leads to increased susceptibility to infections and impaired wound healing. The delayed immune response prolongs the body's fight against pathogens, hindering recovery time. Secondly, age-related muscle loss, or sarcopenia, plays a crucial role. This progressive decline in muscle mass and strength results in decreased physical performance, increased risk of falls, and prolonged recovery from injuries. Furthermore, the associated reduction in metabolic rate elevates the risk of developing obesity, diabetes, and cardiovascular diseases, all of which further impede recovery. Thirdly, osteoporosis and decreased bone mineral density significantly impact resilience. The progressive loss of calcium from bones increases fracture risk, even from minor trauma. The subsequent healing process is considerably slower, potentially resulting in months of recovery time for bone fractures. Fourthly, the decline in cardiovascular and respiratory function contributes substantially to reduced resilience. Weakened cardiac function leads to reduced blood flow, resulting in fatigue and decreased energy levels. Reduced lung elasticity limits oxygen uptake, causing shortness of breath during physical activity and hindering recovery. Finally, the diminished capacity for post-surgical or post-traumatic recovery is a critical factor. Tissue regeneration and cellular repair processes are significantly slowed, increasing the risk of post-operative infections and prolonging the overall recovery period. This complex interplay of physiological declines underscores the importance of proactive measures to maintain physical resilience throughout life. Neurological degeneration and cognitive decline result in neuronal loss, hindering learning, memory, and information processing, and increasing the risk of Alzheimer's and Parkinson's diseases. The impaired ability to cope with stress leads to elevated cortisol levels, causing insomnia, anxiety, and depression, and reducing resilience to pressure, thus negatively impacting mental health. Social isolation and depression are common among the elderly due to the loss of friends and loved ones, leading to loneliness and a decline in motivation. Limited social interaction further contributes to depression and anxiety disorders. The consequences of impaired resilience are significant. Firstly, it elevates the risk of severe illness and mortality. Compromised recovery mechanisms allow diseases to progress more aggressively, potentially transforming minor ailments into life-threatening complications. Influenza, for example, can induce severe pneumonia in the elderly. Secondly, quality of life diminishes considerably. Reduced mobility, musculoskeletal pain, and fatigue are common, leading to decreased independence and increased reliance on others. Thirdly, there is a substantial increase in financial and healthcare burdens. Prolonged treatment, extensive medication, and assistive devices necessitate significant time and financial commitments from both the individual and their family. Improving physical and mental resilience requires a multifaceted approach. Regular exercise is crucial for maintaining muscle mass, strengthening bones and joints, and improving cardiovascular and pulmonary function. A balanced diet, rich in protein for muscle maintenance, calcium and vitamin D for bone health, and low in sugar, salt, and saturated fats, is essential. Adequate sleep, 7 to 8 hours nightly, facilitates optimal recovery, while stress management techniques such as meditation and yoga promote mental well-being. Cognitive stimulation, through activities like reading, games, and language learning, enhances brain function, and consistent social interaction fosters positive mental health. Finally, regular health checkups and preventative measures such as vaccinations are vital for early disease detection and infection prevention. Aging is inevitable, but healthy aging is a choice. To thrive beyond 80, proactive measures are essential. Prioritize physical well-being, cognitive stimulation, and strong social connections. These factors significantly impact longevity. For further insights into extending lifespan, like and subscribe to this channel for future updates. Share this video to empower your loved ones with this knowledge. Comment below. What do you consider the most crucial factor for achieving a long and healthy life beyond 80? Your input is valued.